All right, everybody. My name is Maleh. I'm a software engineer at Groupon, and I'll be talking today about Rails engines patterns. So, what was the inspiration for the talk? There's a big problem in the Rails community. The problem of giant monolithic apps. A lot of the time, people start with a small Ruby on Rails application. They're happy, they're chugging along, delivering features. But then suddenly the business decides to spin off multiple sites based on the same information, one for administration, one for the main users, one for a special set of users. And then all of a sudden, they're rewriting features multiple times, or they're just building one monolithic app that really constitutes multiple apps about different parts of their business. So who here has experienced the monolithic Rails app problem? Okay, a lot of us have. So last year, I used to work for Optiva before I joined Groupon. I was a consultant over there, and I had a chance to consult on a Rails project that was brand new, but the client knew beforehand that they had about 3 problems to tackle with their website. So we wanted to prevent that problem, and the thing that basically helped with it was Rails engines, and that's what we'll be talking about today. So one of the key issues was difficulty reusing functionality, cutting across models, views, and controllers whenever you're building multiple Rails apps that are sharing the same features or some of the features. So say we want to do better and not build a monolithic app, you would break it into multiple apps, but then suddenly you find yourself repeating the same name and address form in all 3 apps, and then repeating the same search map in all 3 apps. And it gets really painful after a while because of redundancy. So you end up with a lot of duplication. So here's an example of what the client, NCSA, a college sports recruiting company, had. This is a feature that enables visitors of the site to basically do a college search map or a college search via a map. So they pick the states that they want to search for colleges under, and they hit the button, and then it basically lists the colleges as well as extra information about the colleges, except each app was going to have its own customizations for it. One app was going to let people display select multiple states at the same time. Another app wanted to let them select one state at a time. And then each app has its own customization of how the results would look like as well. So the typical thing that any Rails developer would do, and I've done that a lot, is you would just duplicate the features and give up. You'd be like, oh, forget software engineering, forget dry, forget any of these things. These ideals apply only on very tiny, small problems. But once you have a big problem like this, you have to duplicate. Well, turns out I was wrong. Rails engines solve the problems. So you can break the common behavior into Rails engines, but still be able to customize the models, controllers, and helpers in each project exactly where needed, as well as the views. So then you get the best of both worlds. You're able to cut down on the redundancy, so you get better maintainability for the code, and still have extensibility, meaning have each application customize the behavior on its in the way it needs. I'll go over more technical details of how to use them in later slides. But the example domain that we were working with was they had a high school recruiting Rails app. So the bottom layer is actually that Rails applications. So a high school recruiting app, a public student profiles app, and an athlete recruiting app. The 3 of them needed a college search map, which is the thing that I showed you earlier. So then we were able to put that in a search map Rails engine and have all 3 apps reuse it. Also, the 3 of them had similar common domain elements. So we also put those in another Rails engine. So this is one example of the college search map in one of the apps. This is how it looks like in another app. Same exact code. The engine and the logic, the common logic and common presentation elements are all in the engine, including the map. In fact, one app had the map at, say, the full size of it, and another app had it at 70%. We were still able to do that kind of customization easily without having to duplicate data. One of them needed to list the state names, the other didn't. And also look at the search bar. The styling on them is different as well. So what's a Rails engine? Before I continue, who here knows what a Rails engine is already? Okay, that's a relatively good number. Who here is actively using Rails engines? Okay, good. So it's not the same hands, but that's good. I mean, it should have been a subset, but regardless, some people may have looked into it and not, forget mathematics and logic, but yeah, some people may have looked into it and didn't buy into it. And I was one like that a few years ago till I tried it on that project. So let's go over it. It's simply a Ruby gem plus MVC stack elements. That's it. So I mean, a lot of people have this big fear of what Rails engines is, thinking it's this huge, complicated technology that they don't want to put into their project and complicate their lives with. But really, people already use Ruby gems. I know a lot of Rails developers, and I've worked on projects where they actually use Ruby gems to extract common logic behavior. So engines is just a step further that lets you also extract MVC elements like models, views, and controllers. So they let you reuse models, views, controllers, and helpers. Even assets, which is very convenient. That's how we were able to reuse that color search map image. Routes, rake tasks, basically generators, anything that you could think of in a Rails app, any element like that could be packaged into an engine. Initializers, RSpec cucumber tests, so you can separate your tests from the main app, push them to the engine, so then you don't have to run the entire test suite on that app every time. You only run the test suites whenever you modify the engine, but then when you're not modifying the engine, you go back to the app and its test suite is slightly smaller because it doesn't have the engine tests. Rack application with middleware, migrations and seed data, and even libraries. So engine definition. So I'm going to go over a very quick tutorial on how to do it. I don't want to get too much into the details of that because the topic of the talk is Rails engine patterns. But since not a lot of people, not everybody here is familiar with the technology specifics, I'm going to cover them briefly. So an engine structure is similar to a Rails app. And it's got the app, config, lib, spec, features directories. The app directory is only there to simulate the engine being an app so that you can run the RSpecs and cucumbers, because the RSpecs and cucumbers need to imagine that you're in an app. Actually, sorry, that was the config directory. The app directory is needed because that's where we put the MVC elements. Config directory is what I was talking about. And I could be wrong, but either way. Under lib, there's an engine name file, kind of like any gem. Any gem would have a file like that. And then there's an engine name / engine.rb file. And you can use Jeweler or any of the libraries that would package an engine into a gem in order to make it a gem and reuse it. So I mean, this is so by engine name, I mean the name of the engine. So like if it's the search map, it would be lib/searchmap.rb, and within it you define what libraries it needs. So like first two lines on the top are just libraries being loaded, and then below it is like some stuff being loaded only for tests. So this is a simple RB file for it. There's better ways of doing this, but this is one example. And then this is the engine RB file. This is where you actually configure the engine with engine features from Rails. And then once it's declared as a gem, you can consume it as a regular gem if it's on a server, a gem server. Or if you're using Git with Bundler, you can just have Bundler read it from a Git repository directly. That was the most productive way we found for my project, because it was an internal company project. They had 3 websites, but they were all internal, so that seemed like the fastest technique. We didn't want to maintain a gem server and deal with any of that. And that also gives you versionability. So we were able to do versionability with Git revisions. That's what the ref is about. Load order. So load order is important. Usually, by default in the past, Rails app files always loaded before the engine files, which is a bit counterintuitive. Because you would think the engine is a library that you can load, but then customize its behavior in your app. But if you're loading the app first, that wouldn't work. So then I strongly recommend to reverse that. That's what we did on all our projects. Meaning have the engine load first and then the app. So then if the engine brings any behavior and then you want to customize it further in the app, you write code in the app to do that. So reversing the load order can happen in one of two ways. If it's an older version of Rails, like Rails 3.1 or below, you had to monkey patch a file called active support/dependencies. There's a guide online on how to do it. With the newer version, they added this thing called config.realties_order that lets you just order the engines before the app, which made it more convenient. I have not tested the second way because we worked with Rails 3.1 at the time, but I wanted to point it out. That's the monkey patch that I mentioned. Make sure to all write it down in your notes because you're going to need it. OK, Ruby code customization. So models, helpers, controllers, any Ruby code, if you declare it in the app with the same file name and path as where it's declared in the engine, your code gets mixed in on top of the engine code. So it's just like Ruby open classes, nothing special. So if you add extra methods, so this allows for adding new methods behavior, replacing existing methods if you want to override something completely, or even extending existing methods like using alias method chain. So one example is like they had a college domain model in the engine that was needed in a lot of apps. And this is a very common problem, like where you have an active record that belongs to, has many. You don't want to, it has a lot of associations, but you don't want to redefine them again in every application, duplicate the code. It's very annoying. So then they defined it once in the engine, and then under each app, so this is one of the apps, they actually just opened the class again and added the extra method specific for that app. So that solves another big problem that I've encountered in the past, which is you try to reuse code, but then you dump all the shared code from the 3 apps into the superclass in the engine, or the one class in the engine. I've seen people do that in libraries, when using libraries. They take all the behavior, put it in one class in the library, and then you use it across 3 apps. But then you open the Ruby file, and it's got like 30 methods, and only 5 of them apply to one app, and 7 apply to another app, and 3 to the third app, say. That's dirty. It's much better to actually keep only the common minimum in the engine, and then each app can contribute its own behavior, so then it's so easy to maintain. Because if you want to maintain something specific to one app, you go to that app. If you need something generic, you go to the engine. OK, so what about view and asset customization? So engine view and asset presentation can also be customized. However, that's by redefining files in the Rails app, which actually completely override the files in the engine. So unlike Ruby files, which are open classes and they get mixed in, images and HTML ERB files don't get mixed in. They just, if you define anything again in the app, it replaces whatever was defined in the engine. So be mindful of that, which is a part of the reason why I came up with some of the Rails engine patterns that will be mentioned in this talk, is to get around this limitation. So examples of files you can override, like ERB and HAML files, depending on what you're using, JavaScript files, CSS files, images. You can override any of that, which is great, because that means you can reuse JavaScript front-end logic, put it completely in the engine, and then only override the JavaScript behavior in one of the apps, say. You can still do that. So it's not just limited to Rails MVC. It's also applicable to client-side MVC. So one example is we have an image college coach HTML ERB, which simply just renders the email body. But then this other app customizes it to include extra information below the email body. So they had to replace the file and then add the extra stuff. So notice how there's a little bit of duplication. That first line is duplicated. There'll be a pattern around getting rid of that duplication later. So what about code management? How do we make developing with engines practical? So each engine lives, the recommendation is to have each engine lives in its own repository independent of the Rails app, meaning don't dump all the code in one repo. Have them in independent repos. And then each engine gets its own gem dependencies. So some engines may have only a few gem dependencies, as opposed to the app, which might have many gem dependencies. And then engines should preferably share the same Ruby version as your Rails app if you can help it. And then as far as typical development process, so the way we've developed day to day was you go make a change in an engine, rake, commit. So you make changes, you keep working. I might work for a whole day in an engine. Like usually test-driven development, like with RSpec or Cucumbers, either way. So I work a whole day with my pair. Like we were an agile team, so we did pair programming. After, say, 7 hours, whatever, 6 hours, at the end of the day, we finished passing all the Cucumber tests. We finished passing all the RSpecs in the engine. The engine is ready for consumption. So now that we've added our new modifications to the engine for that one day, we basically commit and get a new Git revision number. We go back to the app, open gem file, which is the bundler file for defining gem dependencies, and update the Git revision, and then run bundle install again. So that refreshes the app dependency on the engine. Finally, we rake and commit changes in the app, and it's ready for deployment. Of course, if more changes are needed in the engine, then you iterate and go back to step one. So one issue with this process that came up in a pragmatic setting, in like practical day-to-day development, is that it's not as happy as like you just work in the engine, you go and then do your work in the app, and then you're done. Unfortunately, a lot of the times what would happen is you go back to the app, you do some manual testing, you verify the engine behavior, and then you're like, oh, I'm not happy with this, or oh, this partial doesn't look good, or oh, wow, this is not great. So then you have to go back to the engine, make the change, commit again, get a new ref number, go back to the app, put it in gem file, bundle install. So then you end up doing bundle install like 5 times in a day, maybe depending how often you have to go back and forth, which gets really annoying if you end up going over 10 times or 15 times, So that makes it very fast, not practical. So, I could have just, cursed at it and been like, oh, damn, Rails engines suck. Because that's the typical thing we do in the Rails world. We like to blame things. We're like, OK, let's give it one more try before we quit on engines. Let's see what we could do about this. So one thing we came up with that seemed to work was basically symlinking. Just symlink the directory that contains the engine code, engine reference code in the app, to the engine directory itself. Meaning have a symlink from the app to the engine files directly, as opposed to having the app just pull the gem files from the repo. From the Git repo. When we've done that, so we made a rake command that lets you symlink, just like that. We do work. We go back and forth between the engine and the app as many times as we want. Once we're done at the end of the day, that's the point when we actually commit the engine code, generate the Git ref, and plug it into the app. So we only need to do that before having to commit the app and deploy it. So that basically solved the problem and removed that restriction and made our lives much more productive with Rails engines. So then we're able to keep the benefits of maintainability and extensibility at the same time while staying productive. Because also you become more productive when you're not duplicating code. So engine gems. One thing to keep in mind with that technique is if you do that, once you symlink the app to the engine, never run bundle install from within the engine. That causes trouble. Don't run bundle install till you're done with both and you've committed the engine, and then go back to the app and run it. So improved process with that change is, you open a Rails app, you symlink all the engines that need to be symlinked. So you just run that one command, rake engine symlink. And I have it on my blog. You can check it on my blog when I post a link to it later in a sec. I have the rake test that I've been talking about there. You work in the app till you're done without running bundle install. Finally, commit the engines. You go back to the app, you do bundle install, and then you're done. Go ahead. Sure. Oh, okay. Maybe we're just not aware of it. There you go. That's why we do pair programming. We learn new techniques every day, but still, it's not enough. That's why we come to conferences, which, yeah, thanks a lot. Thanks for sharing. Yeah, so the question is, why do we use symlinking when we could have in Gemfile included a gem declaration with a direct local path to where the engine lives, meaning where the files live. So it's an alternative technique to actually us symlinking the gem directory into the engine. That way we can just have the app linked to it directly. It's just a slightly simpler way of doing it. Pardon me? Of course, no. Once you commit the app, you have to make sure that it's configured properly. So yeah, there you go, that's a trade-off already. You have to reset it back and then commit and deploy. So if you forget that, you'll break the server, so yeah. All right, trade-offs. So engines can reuse engines, which in that example that I mentioned earlier, we already have a case of that. The search map also relied on common domain elements like the college model. So not only did the 3 apps need the college model, even the search map did. So it still needed the common domain. So we've had an engine reuse an engine, and that's completely possible. You can totally do it. It's great. Now, when multiple levels of depth are involved, though, you have to commit and update. You have to commit the repos for the engines in the app from the bottom up. So what that means is, for example, you have engine 2. So you have the app, which sits on top of engine 1, which sits on top of engine 2. So what you do is, once you're ready to commit your changes, after you finish development, during the whole day, you basically commit the changes in engine 2. Then you go to engine 1, update the gem file, and commit it. And then you go to the app and update the gem file and commit it. Okay, engine configuration. So engines can be configured to customize rack middleware, load paths, generators, Rails component path, etc. So I mean, you're not limited to the default Rails way of where you place your controllers, models, and views. You can actually update the path. So with that statement, we've updated the path where controllers should live in that engine to lib controllers instead of app controllers. So I mean, you have options if you ever need that. Go to edgeapi.rubyonrails.org classes Rails engine online to get more details on how to do that. Also, I mean, just briefly to mention, to avoid any namespace clashing in the use of engines, which could happen if you publish an engine publicly for public consumption, you want to make it an isolated engine, meaning you want to have all its components namespace so that the app that consumes it doesn't get affected. In an internal project, you might want to save time and not do that or not worry too much about that, but it's a good practice either way. All right, so before I continue, I'll take 2 questions, if there are any. Go ahead.
You were talking about using open classes amongst engines for defining different behavior. What do you do if 2 engines use the same open class to define the same method?
Okay, so the gentleman asked that we talked about how you can rely on open classes in Ruby in order to override behavior in an engine. What if 2 projects had the same name for a class, but with a different meaning?
No, the same, like are opening the same class, but they both define the same method.
Oh, if 2 projects define the same method, each project gets the method that it defines on top of the engine. So they would both replace the engine's method completely. So this is just a Ruby thing. If you ever redefine a method by opening a class, it gets redefined.
Yeah, but if in the end they're all running under the same project, which method?
No, they're not running under the same project. Each project lives in its own Git repo as well. So those 3 projects, 1 per repo. I'm going to take another question. Go ahead.
On the models and reversing loads for engines,
Okay.
what advantage is there to more or less unpatching your own class and instead just creating a module that knows to include for each project?
Okay, so the question is, given that we want to invert the load path and to have the app monkey patch engine files, what's the advantage between that and between actually having the engine define a module?
Having an engine node to include a module for each of the projects.
Right, having the engine to node include a module for each of the projects. That creates a dependency back from the engine to the project, which will then defeat the purpose of having an engine in a way, because the nice thing about engines is their behavior is completely decoupled from the application that uses them. So when you're maintaining their code, you don't need context on the app. You only work, so you improve your productivity by working only within the context of that tiny problem of, say, the college search map. But if I had to worry about the high school RMS application while I'm working on college search map, then maintenance of the code becomes harder. All right, so let's go over Rails engine patterns. So the goals behind coming up with the patterns were several things that came up that we wanted to improve upon. So like we wanted to keep the engine code agnostic of app customizations, which is the thing I just mentioned to the gentleman. Prevent bidirectional coupling. So we wanted to keep it linear or unidirectional in order to make reasoning about the code easier. Because like I mentioned, then you reason about the app-specific logic within the app, and you only reason about the engine logic within the engine. You never have to think about both at the same time. So it minimizes cognitive overload, which is what Noel Rappin was talking about in the first lightning talk yesterday. So I mean, this is one more way of reducing cognitive overload, making you more productive in development. And you avoid app-dependent conditionals, which make the code dirty and harder to maintain. Like, you would hate to see something like, if app 1 do this, if app 2 do that. That's a big no-no, because that's like immediately you're defeating the purpose of using engines to begin with. So first pattern, common domain. That pattern immediately emerged, and it's partially inspired by a recommendation from the book Domain-Driven Design, which is once you have multiple projects sharing a domain, you might want to extract that domain into its own module. So Rails engines lets you do that. They let you basically make an engine that have the common domain. But it goes a step further. Not only does it let you have the common domain models, but also common domain view elements. So for example, you might need CRUD operations on an address model, as well as an address form. A lot of applications have a name and address form, or just an address form. You don't want to reduplicate. That's another big problem with Rails and managing multiple apps was us rewriting the CRUD actions for an address controller every time we wrote a new Rails app, because there's slight differences in each app. But then if you could just put all that common behavior in an engine, problem solved. You don't have to do that duplication anymore. Need to reuse, for example, need to reuse address model and form entry behavior. So solution in the engine include the basic domain models, only base behavior. Don't put any app-specific implementation in the engine, as well as common associations. So if one app will need one extra association from user to admin security information, for example. Say the administration app needs that, only put it in the administration app. Don't declare that association on the on the common domain model to keep the code as clean as possible in the engine. And then in each app, there's where you can add extra associations, specific behavior, custom views, custom controllers, etc., or even custom methods added to any of those models. When you can also, of course, share routes, because you will need that when you're sharing, say, CRUD behavior in an engine. So make sure when you define the routes to use Rails application, not the application name. So like, don't say, I don't know, like high school RMS.routes.draw. That's wrong. Which was the older way of doing routes in Rails. They use the newer way, which is Rails application routes.draw, because then that decouples the engine from the application that will include it when defining the route. So this is an example of a name and address form. So we end up defining address RB, addresses controller, address route, an address partial, etc. We might have more stuff too. Okay, pattern 2, expose helper. So the problem is we need to customize presentation logic, specifically logic, for a view in one app only, or even multiple apps, but keep it the same in other apps. So an engine might have, like some shared behavior from the engine. You might need a customization on the presentation logic, which only in one app. So I mean, an example is, say you need to gather county for when the user selects a specific state, or there's better examples than that actually, but let's just imagine any sort of logic that you might be doing in the view which you've extracted to a helper, or which you will extract to a helper. You could override the view in the app that's consuming the engine and change that logic if you want. That's one way of dealing with the problem. But if you do that, you end up with some duplication, kind of like what we saw before when I showed you a view overriding another view. So, I mean, solution is extract that logic to a helper in the engine and have the default behavior implemented in it. And then in each app, define that new helper with different customizations. So, for example, say I have an address form, and this is how it looked like originally. It was displaying all fields. Say that one app wanted to customize the behavior, so it overrode the view completely, duplicated the entire form, only for the reason of adding that if government user display address to, otherwise don't, and also if government user display county, otherwise don't. So then how do we solve that problem of duplication? Remove the custom view from the app, add a general requires extended address helper in the engine, define requires extended address in the engine to always return true, and then have it in each app, or in that one app, return government user. So then you end up with something more like this, which is, if requires extended address, do that. Only in the engine, the app will not need to have any of that, will not need to override the view anymore. The app will only override the helper at that point. So then you don't have much duplication anymore. You only add the logic in the app that will customize the behavior. Is that clear? Okay, expose partial. So that's pattern number 3. So we need to have different customizations in one part of the view in multiple apps. So multiple apps want to customize a part of the view. So one app needs an extra neighborhood field within the address form. Another app needs an extra region field. And then other apps might want to keep the address form vanilla with none of that. Again, we don't want to duplicate that form many times to solve the problem, which is the typical first way of solving this. If we want to improve over that, so for example, this is one of the apps. It's adding neighborhood at the bottom before the save button. This is another app adding region. So solution, in the engine, extract the view part that needs customization as a partial. And then in the app, redefine the partial only with customization. So that way you've improved one level. Instead of redefining the complete view, you only redefine a part of it in the app. So that's another way of solving the problem of redundancy when it arises. This way is helpful when there's not much logic involved. That's why we didn't use a helper. There's no need for a helper. You can just do it with a partial. So what you do is in the engine, you define an address extra fields partial that you keep empty. And then you redefine that partial in the app with the extra fields that are needed. And then within the engine code at the bottom, as you see, you render that partial. Okay, pattern number 4, extension points. Anybody heard of this pattern before? Okay, I saw a few hands lift up. This was mentioned. Okay, so this pattern is a very, very common pattern in the Eclipse IDE implementation in Java. I used to be an Eclipse plugin developer in a previous job with Java. And we built extension points as well as reused extension points. And the pattern originally came from a book by Uncle Bob. So we were able to appropriate that pattern to Rails engines and somehow morph that pattern and shift it to fit our needs, without all the extra complexity that it had, say, in Eclipse, or the original way it was mentioned in Uncle Bob's book. So what's the problem? Multiple apps need to contribute data to a view in different places. So I mean, the Eclipse IDE had that problem big time. It's like you have the Eclipse IDE, but then every time you add a plugin, it needs to contribute different pieces to the view, to the Eclipse user interface in different parts of it. So how do you solve it? I mean, in this case, so one way to solve it is basically, actually, let me give you a real Rails problem. So like you might have a list like this that has 3 elements. And then one app, so say 3 apps will need the same header, same navigation bar. So you'll put it in the engine. And then one of the apps might need to add an extra element on top, and another app might need to add an extra element at the bottom of the list. So how do you solve that? And like one third app might want to insert it in between the first 2 elements. That's where the problem really becomes troublesome, like inserting things in between. You don't want to reduplicate that entire code just to insert stuff in between. And also, you don't want to, so we couldn't use the previous pattern. We don't want to extract a partial for between every 2 elements, just for the sake of letting applications insert extra data, arbitrarily anywhere. Because then you have to extract 4 partials in this case, 1 on top, 1 in the second, 1 in the third, 1 in the fourth. So once you've outgrown the previous pattern that I just mentioned, which is extension or expose partial, the way to get around this problem is to use extension point. So what you would do is in the engine, you actually define a helper that renders the view. So you define a helper that renders that list, but with extra intelligence. You have that helper basically read partials from a directory, an extension directory, and by convention, from the file name of the partial, you can figure out which position it needs to get inserted to and then insert it automatically. So a nice thing about this is you don't have to predefine many partials just for the sake of letting them overridden. You've used the power of putting logic in helpers to do that. And then in each app, you go and define those partials, and problem solved. So I mean, with my client project, the problem arose when they had a table of 8 columns that were showing the search results, but one app needed to insert 2 extra columns after the first column, but before the second column, into that table. The first thing that came to mind, the developers is, oh, we have to duplicate now the entire table. You cannot reuse a table without duplicating it, because you can't. Like, usually you have, if you want to insert something in between, it's tough. But then with extension point, we're able to solve that problem and be able to have the engine accept extensions. So the engine defines an extension point, basically, and then apps basically define extensions that plug into any area in that extension point. That's where the name partially comes from. It's that metaphor. So one app will define row 1 and put stuff in it, and it shows up on top of the original row 1. Another app will define row 4, so then it gets inserted at that index, and it shows up at the bottom. All right. So before I continue, I'll take 2 more questions. Go ahead.
Migrations. How do you manage migrations? Because if your main core model has like 5 models, you want to keep their migration in sync, and then you add.
Yeah. So migrations. How do we manage migrations in multiple apps sharing the same common domain? So theoretically, engines support putting migrations in engines. We did not want to go that route, because then we'd have to manage the migrations under each project separately, and then running the migrations become hell. The way we solve that problem is by creating a migrations engine. So so that's one way of doing it. Or by putting the migrations in the common domain engine. So then there's a centralized location for all migrations. But the reason we wanted to put a migrations engine is to keep that clean and separate from everything else. So we had one engine that was just responsible for migrations, and that's where we dumped all of them. And then we only run migrations from that. Second question? Go ahead. Could you speak a little louder, please? Mm-hmm. Mm-hmm. Okay. Right. Right. That would be possible for simple cases, but if you need so I mean, the question was, with the extension point, we're relying on a convention, which might make it harder to discern where the code for a particular list or table lives. So where does that column live? Is it on the app or the engine? So it might make maintenance slightly harder. So the gentleman was suggesting having the helper take a block, and the block doing some of the work. If you can somehow make that work with an arbitrary index, sure, that sounds like that might be a better solution. Pardon me? Right. Yep. Yeah, so the suggestion is to solve the problem by having a block that, say, takes an array or a hash that will basically let you insert the elements. It's definitely plausible. It'll involve a little bit of like the apps writing some logic code as opposed to simply declaring an HTML ARB file. So like there's a slight trade-off for that, but it's definitely plausible. It might be a better solution and cleaner. All right, so pattern number 5, configurable features. That's the level of customizability that you might reach once you've exceeded the last 3 patterns that I mentioned. So when a helper, a partial, and an extension point couldn't help you, you might need that pattern. So this is basically different apps need different features from an engine in different combinations. So this is as simple to solve as simply having the engine define configuration options, and then having each app override the configuration options. And you can make that in a YAML. So you can have the engine have an engine config YAML that has, say, enable address extensions true, enable address headers true. But then each app can override that YAML and configure it to the work it needs. So the engine will use that with conditionals, of course. Like it'll basically look up those config options, and based on a config option, it'll enable or disable a piece of the engine. So that concludes the engine patterns. So let's go over Rails engine costs. Because as responsible software developers, we want to always be aware of the trade-offs. Not everything is just positive. Like you need to be aware of the cost as well, and then responsibly make a decision. Be like, okay, I want to take this or not. So some of the costs associated with engines is overhead in establishing a new Rails engine for a gem project. So there's a little bit of work, not much really, but I mean, it took like half an hour maybe to establish, or maybe a little less, like to add a new engine. But there's a little bit of work and complexity in adding a new engine. You still have to do, so even with symlinking, you still have to switch a lot between 2 apps, or 2 editors, or 2 whatever context in order to maintain your app. So I mean, it's not that bad. We minimize the cost by using symlinking or other possible ways, like having the gem file linked directly to the engine. But there's still a little bit of cost associated with that process. So unless you really need to extract something as an engine, don't do it. Like if you have behavior that is only needed in one app, even if it's generic and you don't know that it's going to be needed in another app, you might not want to extract it right away. You might want to extract it later. I mean, there's other reasons for using engines, like offloading the tests to make sure the tests of the main app run faster without the heavy load of the test of all the features that it has that you can extract into engines. But so I mean, you need to pick your battles there, like make your own decisions about that. And then upgrade of ref numbers and gem file in every commit. That has a little bit of cost. What are the benefits? So code reuse across all application layers. So that's great. Now we can reuse views, we can reuse controllers, even JavaScript. Better maintainability because you have independent project code bases. Cleanly defined boundaries between the project and the engines. Whenever you're solving a problem on a feature, you only focus on that feature. When you're solving an app problem, you go to the app. Also, if an engine, if a feature doesn't change often, if you know this feature hasn't changed in the last 6 months and its tests are taking a long time to run, so then you can offload it to an engine, so then the project test will run faster. So that's a great benefit. That was a great benefit in productivity. Like for my client, at the time, we were able to shave minutes from the test suite by simply offloading the things that change rarely to an engine. All right, big question. Engines versus services. So that's a question that came up a lot whenever I've talked to somebody about Rails engines or somebody asked me about my experience with them. In fact, a gentleman just yesterday at the billiards place was telling me that every time he's considered an engine, he's like, oh, but why don't we just extract that MVC behavior into a web service instead and have the app reuse it? And what I said immediately was, it's shades of gray. It's not the same. Think of it as, again, as responsible developers, you want to know the pros and cons of every approach and then make your decision, not just, like say, oh, I like services, they're already working without, because there are differences. So engines are better when reusing small MVC features, especially when they're domain independent. So you might have a view like this called a search map that has no dependencies on any domain models. Why would you make that a service? It's not a service, it's just a view elements. It's just I have a view logic that will have a map that's clickable, that you can click it and then it will take you to a search results page. You could design the engine to be completely unplugged from the domain model, from the database, so then you can reuse it across many apps as a library, as a gem, as a very useful gem, with no need to do a service whatsoever. In fact, it doesn't make sense to be a service. It's not a service. There's no data involved. You might want to prefer to avoid network and infrastructure overhead when establishing a service, because the price, so I was just talking about the cost of an engine. The cost of a service is much higher. It's much more expensive to configure an engine, run it on its own server, write code to consume it, do all of that. So again, it's like two shades of gray. Think of it as you start one monolithic Rails app, you move on to maybe multiple apps, and then engines, and then finally services. Finally, you might want to extract and quickly reuse a feature. So even something that might fit a service, if you're using it internally at a company, you might not care to make it a service yet, because there's too much overhead in creating a service. So it might be much easier to make it as an engine first. But then later, as an agile developer, when you feel the need to expose it as a service, you can convert an engine easily to a service. Services are better when reusing larger MVC features that depend on domain data, especially if you want to consume them in another programming language. So if you're working in Ruby on Rails across all your projects, you don't have that problem. But once you need to have Java applications or other clients outside the company, outside the organization boundaries consume the feature, then you probably want it to be a service. Also, you might want to scale up the feature performance independently of the application. So once you've noticed that this particular feature is getting hit a lot, you might want to offload it into its own database and then optimize it in complete isolation of the application so that you decouple performance effects between the app and that specific feature. That could be a great technique. So like this is where a service would shine, actually, in that scenario. So, like I mentioned, to keep an easier to maintain agile code base, you probably want to start simple and then move incrementally towards a more complex architecture. So you first extract an MVC feature as an engine, and then you can convert it to a service when the need arises. Just to review, we went over the basics of Rails engines, went over Rails engines patterns, improved productivity tips at one point, and then finally summary of benefits and trade-offs. Thank you, everybody. You can find more information over here, and this is my contact info.